Hello everyone. Today, Shreyans will tell you the teach you automata theory. Under automata theory, we will study NFA and DFA. So, what is automata theory? Automata theory is a computation of the uh, the languages. It is a computation theory, and so what's it consists of? It mainly consists of LAG, which means language, automata, and grammar. So, what a language is? Language here are of two types. First, finite and infinite. Language can be, to study language, we need to study strings. As we have seen in our programs, we just write A, comma, B as strings, A, B. These are what? These are strings. 1, 1, 0, 1. All these are strings. So the combination, so the what the sequences we can make from these uh, strings A comma B is known as language. Here all the sequence from this A and B can be A, B, A, B, B, A, then A, A, B, and just like this. These are all the uh, these are all the language of strings A and B. So what if we come to the finite language, here the length is here is defined. Length means A and B, which is of above 2 length. Length here is 2, and in A and B length is 1 1 2. Here AAB has length 3. So if we bound to length 2, the all the languages made can be made from A and B are A, B, B, A, AA, BB. These are all the languages. So and we can also make, these are the languages. Here length is defined like this. So what are the infinite language? In infinite language we can see A, and then A, B, 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 and many infinite B's can also come here. So all the sequence of the A and B can be much greater than if we don't define the length. So this can be, language can be infinite. So this infinite language can be greater than. Some more examples of finite language: if the length is 3, length here is 3, so it can be A, B, A, B, 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 and much some more will there, but these sequence will be some finite, not like infinite. Here you cannot uh, go to after some certain limits of A or B. So what here are the some notations for the for the to see the automata. Here q is a finite state. Here it can be represented like this q, and this is a finite state, symbol of finite state, like here you can see as these is are the finite state. A and B are can be counted, can be count the states can be counted here. And this is the transition state, where it means that the transition, if we go from one state to another state, this is this this is called a transition phase, and this symbol just says it is a transition function. So and q naught, q0 is the initial state, which is represented like this by this arrow, and q0 tends to q naught is a part of a state, but it is always represented by this arrow. And f is a set of final state, which is represented by double circles, a circle inside circle. This means that that here states ends. So now come to the finite automata. What finite automata is? There are two types basically: finite automata and infinite. Infinite, the language is finite and represented by this sign. And in in infinite automata, language are also infinite. Infinite automata consist of DFA, NFA, Mealy machine, Moore machine. DFA is deterministic finite automata, and NFA means non-deterministic finite automata. To study them, we'll see what a grammar is. Grammar, here you can see a grammar G is defined as quadruple. Here means G is set of VTPS. VTPS means V for variable, T for terminals, P for production rule, and S for start. As you can see uh, this is S. S means start. Here from here our grammar starts, and A and B are some terminal points. As you can see, terminal points. So A and B are terminal points which are in small letters, and the capital letter represents a variable where the stores some input. So, and this means that it all this grammar consists of ASB and epsilon. Epsilon means that the grammar has no null, which means uh, epsilon, the state is empty. So in this, what minimum, what the grammar can be made, as we can see, this can be epsilon, no any sign. It can be ASB, it can be AASBB. How AASBB? If we put AASBB in this variable S, then it will be AASBB. After again putting ASBB in this variable S, it will be triple A as triple B. So as this is epsilon, if we put epsilon in this A as B, this will be AB. If we put again, if we put epsilon in this A as BB, this will be A square B square. In this S, if we put epsilon, then A square B square. Then again, if we put, this will be A cube B cube. Then after that, A power 4 B power 4, till then A power n and B power n, where n is greater than equals to 0. So for DFA, deterministic finite automata, if we see, it consists, it's a set of finite states. A and B are this sigma are the languages, and this is a transition symbol, and Q naught start F for final state. String starting with A. This is a simple question for DFA. String starting with A only. Here A, double A, triple A, AB can be defined, but BA, if we come to BA, this cannot possible, as starting string is not starting with A, it is starting with B. So as you can see this, uh, it always starts with this arrow point Q0. Q0 is a initial state, and Q1 will be the final state, which is represented by this double circles. And for making a DFA, we need to start with some minimum string. As the length of minimum string is 1, so uh, our states will be 1 plus 1, which means 2, Q0 and Q1. So we need to set the state the minimum state in this point, and after this we need to set the B and A in every state. As in Q0 A is defined, but in Q0 B is not defined. So can a B comes like this? uh, I think no. Why? If we comes start from here and again comes B, then goes A, B A, this cannot happens. This was rejected, so B cannot come here. So this will be wrong. uh then here comes, then where the B will go? B will go to the a separate state QZ, which is called dead state. Here here the B string will trap in QZ. If we define A and B, A comma B, after coming B, then trapping here, it cannot go outside the loop. So after this, B, if B will loop trapped, A will comes here, and as you can see at it in that final state, I have defined A and B in self loop. Now see why. I can also do it like this, A B, but this was wrong. Why? Let's see. If I've done like this for A, then if it will go A, then again A, then which means A A A A A, which means A will be of even, but odd A also can come. So this was wrong. Now if I had gone for B, after going this A B B A B A, the same, it will be the same thing. B can be of a b a b a b. This will be the values, but except this a b a also can comes, a can also comes. So to avoid this, I have just not done this. You can put a and b in a self loop so that as many a and b can come. Now let's see if now to let's solve some example. Construct a DFA which accept the language of all strings containing a and containing a. So in this point, the inputs are a and b, and what's these strings can be made from these are a, double a, triple a, b a, b, a b, b, and many more. So we will start with a initial state q0. And how many states? As the minimum state is a, the length is 1, so we will go for q0 and q1, two states, and this will be the end state. So a is defined here, which means a is always defined like this. For b in q0 will go comes like this, containing a now. So we need to see, we can define b here. After this b and a, you can see this b and a will comes like here. B a can be accepted. Then b, after b and a, we need to define a and b in the q1 state. So for a state, if I will do in a previous state, this will represent in the even number of odds with a, but odd number of a's can also come. So I will need to define a here. For b also here. So this will be the required answer for constructor DFA which accept a language of all strings starting with A and ending with B. We need to start a Q0 starting state Q0 starting with A and ending with B. First make a language here. What are the language starting with A and ending with B? A and B can come, A can come, then B can come, then A, B can come. A and B are at the fixed point. So the minimum state length is 2, and so the states can be 3. Q plus 1, Q plus 2, Q0, Q1, Q2. 3 states. First, we need to define A at the starting phase as A is placed here, and for B at here. So the minimum possible is A and B. For B at Q0, Q0 can come here. I think no, as B it cannot start, the string cannot start from B. So we need to uh, put it in that state QZ. For Q1, A is not defined, so A will be in a self loop as A, B can come here. This is the final state. A is also defined. Now comes at the end for A and B. For at the end where A will go, A cannot come here, as the final state should be B. So A will goes in at the that state, and the at the end you need to define B. So B should be here. So the every string starting with A and ending with B will be accepted. So in NFA, what is NFA? Non-deterministic finite automata. Here that configuration is allowed, which means Q0 to Q1 can be transist by a epsilon uh, state, which means no input should can allowed, and you don't need to define every input here. For example, for 0, if you have defined here for 1, this is the this is a valid NFA. You don't need to define 0 here or here. So this is allowed in NFA. This is much simple than DFA. So multiple choices are available corresponding to an input, which means this only. You can go as many as state using a single input. For example, 1, 1. Here the inputs are twice, but in DFA, the inputs are fixed. For one, you need to set only one. You can go in one transition only. Non-deterministic feature is not associated with real computers, and designing and understanding is easy for NFA. Now, now let's see NFA of all binary strings in which second last bit is 1. What will be the NFA for this question? Uh, to make the NFA of all binary strings in which second last bit is 1, which means 1, 1 here is defined. So the you can see as the string will be 0 or 1. Starting can be 0 or 1. Second last is 1, and the ending can also be 0 or 1. This star denotes here as much as the strings. For example, 0 1 0 1 0 1 1 1 1 0, as many as. But at the end, 0 or 1, 0 slash 1, and the second last position here is 1, which is set already here. So if we go to here, at the what the NFA will be made here is, you can see Q naught, Q0. Here is starting state, uh, where 0 or 1 you need to define, and 1 is there is